Hi, welcome to the second video in Duck Robotics FTC introduction series. So this video is going to be the behind the scenes of building a competition robot, and this is by Stella and Alex.
So our robot for Into the Deep includes a claw in the front to capture specimens, an arm and gecko wheels to capture samples, and a Go Builder slides to power the arms, a simple chassis drivetrain used while using mechanism wheels, and our team number and accessories on the sides.
So the first step when you're building a robot is to brainstorm and identify problems in the season. So we're using our Into the Deep season as an example. So it's important to determine your strategy, goals, and obstacles. So for example, a strategy that we used last year is to focus only on samples. This was very early in the season, and later we changed this to focus on both samples and specimen. But our starting goal was to focus only on samples. So it's also important to find concepts online and inspiration. So, for example, a robot in 3 days is a really good resource, and a lot of other FTC teams also post their early designs on YouTube. It's also important to brainstorm possible design through sketches to get your ideas out. So, as you can see, here are some sketches of possible designs that we created.
So step 2 is CADing. So CADing stands for computer aided design, and you can use it on different platforms. Some may include Onshape, SolidWorks, and Fusion 360. So why use CAD? So it allows you to digitally visual a 3D model of your robot. It helps you determine potential problems early on, so you don't have to deal with it once you actually built your robot, and it makes your designing process more efficient, and it helps you figure out what parts you may need. And design and print your own custom parts. If your team has a 3D printer, it's going to be really helpful because it's pretty durable and it's really light, so it may make your robot move fast.
The third step is to prototype and build. So using your CAD designs, you can create prototypes, which helps you determine what works and what doesn't work. So for certain prototypes, it's useful to use cheap materials like cardboard or wood so that you're not wasting money on prototypes. And when you're building, it's you should always start from the drivetrain as your base and then continue adding additional parts like your intake and your outtake and additional accessories. Lastly, good wiring is very important for avoiding electrical issues. Like, for example, last season, we sometimes had a dead robot in the middle of the game because our wiring, our robot disconnected, which is very bad and it prevents you from having an effective game.
Finally, you want to reflect and repeat. So after you're done building, it is important to reflect and determine what needs to improve on the robot. So you want to test with teleop so you can activate every single mechanism on your robot and make sure it's functional, reliable, and it's stable. You want to change your strategies and goals to make sure you maximize efficiency on your robot. Say, if you have a robot that's really good at scoring samples, but you decide to add a little mechanism that scores specimens, and you decide to score specimens, that's not a really good use for your robot. So you want to change strategies and goals to see what scores you the most points. Next, improve robot components. So you want to make sure your components can be changed into better versions of themselves. So this also, you want to document down in your portfolio to show the judges that you have. There's multiple steps to where your final robot to lead to your final robot. So down here on the bottom left, you see this is our first iteration of our intake. It was decent, but it could be improved. So for our second iteration, we added 3 gecko wheels plus a bigger base to hold the samples, and this made it easier because there was a bigger mass to intake it. Next, for our first iteration of our arm mechanism, we used two 45 kilogram servos. But this didn't work because the arm was really heavy, and while turning it, the momentum would make the servos disconnect. So we used for our second iteration, we created multiple prototypes and landed on a design that used a motor. So the motor it was really powerful, though it had a really low RPM, but it had high torque. So this helped us move the arm back and forth in game really quickly.
Thank you. If you have any questions, please email ducksrobotics@gmail.com and follow our Instagram page, Duck Robotics. Follow for our next video.